Okay. All right, hopefully I'll get this to work right. This is my fourth attempt at trying to record this amazing lesson. This is it. Now I'm breaking it. I'm gonna take the computer and throw it out the door. How about that? All right, here we go. I don't remember what I said the first 2 or 3 times. Essentially, we're going to learn in Module 7 about triangles and the Pythagorean theorem. Kind of fun stuff. You'll like the geometry parts. Here are some of the vocabulary words that you'll become very well acquainted with here in the next couple of weeks, or week and a half or so. Keep in mind, some of my favorite things. Yes. Okay, here we go. Uh, First lesson is going to be on angle relationships and parallel lines. You will be able to use the relationships between angles to find measures of missing angles. It'll be like a detective. It's kind of thinking about it, that's essentially what we're doing. Here are the vocabulary words you'll need to learn. I want you to add to this list vertical angles. All right, what angle is a bow tie angle? Let's take a look at some of these angles we'll talk about right now. We're going to learn about alternate exterior, alternate interior, corresponding exterior, interior, parallel. Oh my gosh, so much stuff. Basically, you're first going to learn about parallel lines. So everything has to do with parallel lines. Parallel lines never intersect. On a plane, will intersect. I'll take a parallel line, take a parallel line, and move a transversal through it. Okay, it cuts it, it transverses through the different parallel lines. When it does it, it makes angles. You'll see it written in different ways. Angle names, angle measure numbers like that. Ways they'll show that. Now, as we go through it with our parallel lines, you'll next learn that sometimes the parallel lines are transversal, and it will make a perpendicular angle. So sometimes you'll see we'll have two sets of parallel lines, and then we'll have a transversal that goes through it, straight up and down. It forms a 90-degree angle. It forms one 90-degree, it's going to form a whole bunch of 90-degree angles. Okay? So this is a perpendicular line. You'll see it look like this, or like this. Sometimes like this. That's what perpendicular means. So L is perpendicular line L is perpendicular line M. Now, as we go further through here, there are parallel lines. We also have symbols for our parallel lines. So look at my parallel lines here. S and that's R. Line S is parallel with line R. You can tell that because of the arrow things. Sometimes you see tick marks. But those are parallel lines. If that's the case, this is our transversal. And that intersects two or more lines. So do more. So look at this case here. Here's our perpendicular line. And the lines, angles are going perpendicular lines, transversal right here. So 1, 2, 3, 4, 5, 6, 7, 8. 4 short angles are made. So it's all perpendicular here. Now, when the transversal intersects the perpendicular lines, you'll have a set of angles. These are interior angles. They're the inside of our parallel lines. And guess what these are called? Guess. You're right. They're called our exterior angles. Now, we'll number them as such. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So you'll see they'll be numbered on the outside. Where angles at. So angle 1 is this angle right here. Angle 8 is this angle right here. And so on and so forth. Those are the exterior angles. So, if I want to figure out interior, exterior, you can see that. If I take a look here, when I take my parallel lines and cut it by transversal, I can actually find the measure angle. So I know it's interior, not exterior. I can do that. Now let's go ahead and just list this out a little bit. I have to highlight them. These are my exterior angles. All this stuff out here is exterior. Okay. That means what's not highlighted is the interior angles. Now, we are able to also designate which angles are corresponding that have the same measurement. So that will give us some very interesting tidbits. So for example, for our interior angles, angle 4 corresponds and has the same measure as angle 6. Those are alternate exterior angles. Alternate interior angles. And it means they correspond to this is the measure of angle 4 is congruent to the measure of angle 6. So I have the measure of angle 3 is congruent to the measure of angle, guess what, 5. These are alternate interior. Here's my transversal. And I'm on the alternate sides of my transversal. Alternate sides of my transversal. So opposite. Interior angles are interior angles that line opposite sides of the transversal. It's not just it, but it's all. They're the same measurements. The same thing goes for alternate exterior. I have one, and guess what? One on the alternate side goes down 7. We got it. One measure of angle 1 is congruent to the measure of angle 7. Then I have the measure of angle dose and angle 8. 2 and 8. 2 and 8. Those two values are also of the same measure. Now, the one thing I want to share with you is, so we got alternate. We do one more thing. Hang on. Corresponding. I forgot what corresponding in the last video we made. Flustered. The corresponding angles are in the same position. So that means I'm in the same slot. So for example, here is 2. 2 is going to correspond with 6. Okay. So you'll notice if I look at the slot, here's my parallel line. And here's my transversal. 2 is in this upper position right here. So look at the corresponding parallel line. In the same slot. That corresponds there. So on the same side, they have corresponding measures. One is going to be with 5. 3 is going to be with 7. And 4 is going to be with 8. Okay, they have the same measurements. Let's pretend this is 120. If I tell you 2 is 120, how much is 1 going to be? Well, we all know that 180 degrees is a straight angle. No matter how many angles have a straight degree measure of a straight line, no matter how many angles are in there, always add up to 180. So this is 120, this has to be 60 exactly. Now we also know that corresponding angles are congruent. So if this is 60, this has to be 60 right here. Isn't that nice? Well, if this is 120, then also corresponding here, 120 is also going to be the same as 2 is the same as 6 because they're corresponding angles. Okay, now let's go even crazier. We know that 4 and 6 are alternate interior; they're the same, so that will also be. And therefore, we know that 6, 5, and 3 are also the same. 6 is also alternate interior. Now, let's go back with our exterior. 60 and 7, angle 1 and angle 7, got to be the same because they're alternate exterior angles. And then 120 is for 2, so 2 and 8 is also the same. They're also alternate exterior angles. Now, keeping that in mind, let's talk about vertical angles. What do you think the vertical angles are? This is the same measure. angle 3 and angle 1 are vertical angles. They make little teeny tiny bow ties. That's like I remember the vertical angles. So vertical angles also are congruent, and they share the same vertices. It's the same vertical right there, on that vertice right there. That's where you get that from. So vertical angles are also congruent. So this helps prove it. Not only are vertical angles congruent, but also I see my alternate corresponding angles here and alternate exteriors. This is alternate exterior, and I have my corresponding. Oh my gosh, vertical angles. I got corresponding. Boom, boom, boom. All sorts of fun stuff. This should actually give you enough information to be able to classify the angles, to do the check, to do this right here. Okay, cross it out, and then to do this right here. Okay, I want you to end up and just write all the answers directly onto this thing right there. Just write it on there. Don't put anything else. Okay. I hope to goodness gracious this worked. If not, I am done. Happy New Year. Okay, bye.